Hello everyone, welcome back. Next session of the belt drive. In this one I am going to take length of open belt drive. In this one, length of the open belt we need to calculate. What is meant by length of the open belt? It's the total length of this belt which is wrapped on the two pulleys for the power transmission. Here this total length whatever is there, it should be a proper length. Otherwise, if it is a too loose, the more length is there, then it may slip over the pulleys. If the length is less, if it is a tightly wrapped over their pulleys, then the belt may break or there may be more friction. And for that, the belt length should be proper, it should be used. To calculate that one, the available data we have to use. The available data what are there? There is a radius of the driver pulley, radius of the driven pulley, center distance between the two pulleys we can know easily, and from that we can calculate the length of belt open belt drive. Then we can properly wrap and power transmission will be have the more efficiency and better performance. To know that one, all the consideration we need to take here, I will continue with this one in the next slide, whatever the considerations are there. That is, here we have considered the two pulleys. The first one is driving pulley is having the radius R1, driven pulley is having the radius R2, and the center distance between the two pulleys is the X. To calculate the total length of the belt, we need to take the sum of these arcs as well as the lengths. For that one, first length L equal to arc length of ABC, this arc length of ABC, and this length CD, then arc length of DEF, then length of FEF. That we have taken. Arc length of ABC plus length CD plus arc length DEF plus length FEF. Okay, then we will write like this. Twice the arc length of BC. ABC can be written as AB plus BC, therefore twice the BC we can write. Plus length CD is equal to length FA, therefore twice the length CD we can write. Plus arc length of DEF can be written as twice the arc length of DE, arc length of D. Since CD equal to FA, CD equal to FA, we can write length CD. Now we will take this length, arc length, in terms of the angles. The two will keep outside. Then this whatever the angle incurred between this arc BC, that is equal to, this is the 90 degree. That is pi by 2. Pi is 180, pi by 2 is equal to 90. Plus of this angle, the pi angle is additional. Therefore, the total angle is pi by 2 plus pi, and the radius multiplied with that one R1, then that will become say arc length BC. That is pi by 2 plus pi R1 plus length CD will keep like that. This one plus here the arc length of D whatever is there. Here it is less than 90 degree. Therefore, pi by 2 minus of this pi will take, multiplied with this radius R2. Pi by 2 minus pi R2, this will give the arc length D. Okay. Then continuation with this one, the first term pi by 2 plus pi into R1 will keep like that. This one length CD is written as the length GC2. How it is that one? Here we will draw another line parallel to CD, that is GC2. GC2, that is a parallel line. Such a way that the length CD is equal to the GC2. Then here the CD equal to GC2, therefore length CD can be written as length GC2, that is written here. length GC, and third term will remain same, pi by 2 minus pi r2. Then continuation again, twice the first term will remain same, pi by 2 plus pi r1 plus second term whatever is there, again we will reconsider this one. In this one, this triangle will take GC1 C2 triangle will take, and for that the whatever this angle is there, okay, for again taken into consideration, this is the 90 and this is pi angle, again we will take the opposite angles here, that is again this becomes a that one 90 and this becomes a pi. That consideration is there. Therefore by taking this one, this angle will become a pi, and for this triangle GC1 C2, this GC2 whatever is there, it will become say adjacent. This is adjacent to this angle, and this GC1 is the opposite. Now GC2 required for us, therefore adjacent is this one, and C1 C2, that is the x distance, becomes a hypotenuse. Then cos pi is equal to, we know by considering this angle, adjacent by hypotenuse. The adjacent is GC2 by this hypotenuse x is equal to cos pi. This is taken. GC2 by x is equal to cos pi. Then therefore we can write GC2 equal to x cos pi, and that is substituted here. This is the x cos pi, length of GC2. Then now what we will take that one, the outside 2 will be remain same, and here we will take the terms common from first and third terms. That is pi by 2 is taken common, and as it is multiplied with r1, that is r1 is kept here, and from the third term pi by 2 multiplied with the r2, here the pi by 2 is taken common, then r2 will be remains, plus of this r2 is taken, that is pi by 2 multiplied with r1 plus r2. Then again the another term is there in this one, there is a pi r1 is there, pi we will take outside common, pi r inside r1 common, taking this one. Then the third term again, this is minus pi r2 is there, therefore pi is taking outside here, then this r2 will be minus r2 remains inside, plus of x cos pi will keep like this only. Then now we will take the 2 inside for all the terms. That's here the pi by 2, the 2 get cancels, pi multiplied with the r1 plus r2, plus of this is 2 pi r1 minus r2, plus of 2x cos pi, and this we will consider as the equation 1. And for this, already I told you that one, length of the belt drive we have to calculate in terms of the radius of the both the pulleys and the center distance between the two pulleys. In this equation we have the angle pi and cos pi, and these should be eliminated, or these should be substituted in terms of the radius and the center distance. To take that one, we will continue from the triangle GC1 C2, again from the triangle GC1 C2. Here now we will take sin pi. Sin, we know that one, sin angle will be opposite by hypotenuse. The opposite is this one, GC1. This again we don't know this distance GC1, but we know the CC1, and this GC is equal to DC2, that is R2. This also we know. Therefore by known values again we will take as for the GC1, that is GC1 equal to CC1 minus of CG. CC1 is the R1, CG is R2. Therefore opposite to GC1 whatever is there, that written as the R1 minus R2. This R1 minus of R2, that will give the GC1 opposite. Hypotenuse will be remain same, that is the center distance between these two pulleys, x, R1 minus R2 by x. Now pi we can write as a sine inverse of R1 minus R2 by x, and that is equal to, we can write as R1 minus R2 by x, since pi is small angle. If the small angle is there, then we can write sine inverse term equal to that angle only, that term only. Okay, that is here pi equal to we got, that is R1 minus R2 by X. That is the consideration. We should know it. If smaller value is there, then we can write sine inverse term directly, that value only. That will take already pi value we got here, then that will write as a equation 2. Then continuation with that one for the cos pi. Cos pi equal to 1 minus sine square pi raised to half. This we know from the mathematics, and that can be written as cos pi equal to 1 minus half of sine square pi by binomial theorem. This we should know it from the mathematics, how the sin cos pi can be written as 1 minus sine square pi raised to half, and that is equal to 1 minus of half of sine square pi by binomial theorem. We should know it. Then here the sine value, pi value, already we know it is R1 minus R2 by 2. Then if you substitute that value, then that will becomes 1 minus of half. This is R1 minus R2 square by X, that is a sine square, this value square. Then now again this cos pi value also we got in terms of the R1 minus R2 by X. Then 1 minus of half R1 minus R2 by X square, this is taken as the equation 3. Now we will substitute this equation 2 and equation 3 in equation 1. Now L equal to pi R1 plus R2 remains same. Then 2 into this pi R1 minus R2 by X multiplied with this R1 minus R2. Then plus of the 2x remains same. Cos pi equal to 1 minus of, this is taken inside, that is a square we did separately, that is R1 minus R2 square in the numerator, and denominator this 2 into x square remains. Continuation with simplification of this one. The first term will be remain same, pi R1 plus R2, and 2 multiplied with this R1 minus R2, the two terms if you multiply will have, that is R1 minus R2 square by X. Okay, this term we got. Plus of, we'll take this 2x inside, 2x, this first term 2x into 1, 2x, minus of 2x. Okay, in this one, here the 2 get cancels, and the square is there, x square, 1x get cancels. Then in the numerator R1 minus R2 square it will remains. In the denominator only x remains. 2 get cancels, 1x and 1x get cancelled, therefore x only remains. Therefore, and this term we got. Now this first term pi R1 plus R2 whatever is there, it will remain same. The second term twice the R1 minus R2 square by X is there, and here one term negative is there, R1 minus R2 square by X. Then if you subtract one term from this second term, we will have the R1 minus R2 square by X plus of this 2x. This is the length of the open belt, and which is in terms of the radius of the driving pulley and driven pulley and center distance between the two pulleys. From that we can calculate easily, and that we can use in our regular application in the industry. Thank you for watching. Subscribe my channel for getting some other videos. Thank you once again.